All right. All right, let's remove everything for yesterday, then we start afresh. The different version of explanation. Let's hope today to be more clear. So I was trying to find strategies to make you understand more better. So I think you will get it right today. Okay. Okay. So let's start. Let's start. Where should we start? We start. Remember, the question itself is saying, what is our question? Let's go to the question first before we start. Show that grad squared of log r is the same as 1 over r squared. That is what we are supposed to what? To show, class. Is it clear? Yes. So once you have arrived where you are showing that, then we are done. That is our mission. We want to show that grad squared log r is equivalent to 1 over r squared. Then on the top equation, which is b, we have been told that grad fr, any function that is a function of r, that expression can be written as is equals to r as a vector divided by r, which is the scalar, df dr. We proved this one already. So we are going to be using that very same concept when we are differentiating, when we are not differentiating, when we are trying to show that. So how am I going to use the above equation, which was proved in B? We are going to say that this can also be written as grad fr. I'm still at B. I have not gone to C yet. I'm still at B. So that grad fr at B, which we proved, can be written as 1 over r. If I take this r to stand on its own, it's on the denominator. So it's 1 over r. That's what I did. Then the r, that one which is bold, this one, it's a vector. So it can be written as r as a vector like that. Then df dr, if you want to see it clearly like that. So you are allowed to separate it like that. It's allowed like that. Can you see it, class?
Yes.
Right. In such a way that if I am to square this expression which I'm having here above, let's say, suppose I have grad squared of fr. Suppose I have grad squared of fr. How am I going to relate this equation? So yesterday, where I said we are supposed to partialize, of course, grad squared r, it means partial derivative, second time. It's correct like that. But in this case, once you have already given the formula for the above, how are you going to relate grad squared? We are squaring everything which is above. What do I mean? You are coming here, you have squared everything, this whole term, you are squaring it. This whole term, you are squaring it. That is the new strategy which I'm going to give you. You are squaring the whole term. And also on the left, when you square the left, it's an equation. even the right, you must also what? You must also square the what? The left-hand side. So which means it's squared. Any question here?
So our squaring is because we have to use the Z squared.
Yes. Yes. That is why I'm squaring, because I want to come to this concept, but yet now I'm only in FR. So I want you to see the relationship between the B and the C. So if it was grad of FR squared, which means it will be the partial derivative squared, which will be that one which I've written down. So how will the right-hand side look like now? That is, so we are going to square 1 over R. When you square it, what are you going to get? 1 over what? R squared. Do we agree? Do you agree there, class? Yes. Then squaring a df dr. When you want to square it, it means you are differentiating twice in terms of df dr. That's why we are going to introduce ddf. Sorry, ddr of what is inside. So in other words, I'm saying in order for me to get d squared f dr squared, it's like this. Let me just put it as side working. I want to square. When I square df dr, when you square it, it's like you are doing the second partial derivative. You are going to get d squared f over dr squared. That's what you are going to get, which is the same as saying d dr multiplied by df dr. Any question here? In terms of squaring df dr, which means here we have squared df dr. This is the one that we have squared, df dr. Where is the square coming from? This idea that you are squaring what is inside the bracket. So which means that what I'm going to be having inside the ddr, I've put it outside. Then the df, I'll put it inside the bracket. But what is that r as a vector which has been squared? So that r is a vector. We are going to square it. It's going to be r squared. Then we know it's a what? The vector. And then df dr. Then you close bracket. That is the squaring part. When I square that grad f. So now I want to hear your input before I go any further, because we don't want to go backward like what we did yesterday. We've already been far. Now we start going back. There is a side working, which was on the left, where I squared df dr squared. This is how you can write df dr squared. And r as a vector, when you square it, you are going to get r as a vector, then you square it. It can't cancel with that r at the denominator, because the other one is a vector, then the other one is a what? Is a scalar. Any question? Any question?
Yes.
Ask. Let's ask. Let's ask here, because we are going to use this same concept to solve for the next one, where we are given now, instead of grad squared fr, a function of r, now we are going to be given grad squared log r. So we are supposed to be using the same concept. So let's see. Here there are only 3 workings here. The one which is on the left side, then the first, top, and bottom. So if I'm having a question, refer them like that so that I clarify.
So how I understand it, inside the bracket, they are the vector.
Just wait a bit. There's an echo here. want to see what is the problem. Let's wait a bit. Maybe the mic is on. So let me just check what is the problem. Right. Let me just finalize it, please. It's a problem, a bit minor problem. How far you can talk now? Maybe I can hear you. I was trying to change the echo. Let's go. Let's continue. Hello?
Hello, yes.
Hi.
So I was saying,
Yes.
the way I understood it,
Yes. How did you understand it? Continue, I can hear you.
You are
can you
muted.
hear me now?
Hello?
Yeah. Hello, can you hear me now?
Yeah, it's a bit of network. You may talk, let's hear. I can't hear you.
Can you hear me?
Yes, yes, now it's better now, yes.
Okay.
So I was saying,
Mm.
how I understood it.
Mm.
You differentiate. You squared the r the
I
vector.
swear. Yeah.
Yes, and you also squared the df.
Mm.
The FDR, right? So
Yes,
on the
that's
part of the FDR, that's where you found the squared S over the R squared. So you just split it as I'm not sure if you differentiate it or you just split it.
no, there's no differentiation there. I'm just squaring. I did not differentiate. I'm just squaring.
Oh, yes.
Today, yes, I did not differentiate. I just squared. I squared the left, I squared the right. I did not differentiate.
So you
I'm
said
just
that,
squaring.
the square S over the R, so it's same as D over the R multiplied by the S over the R.
Yes,
So that's
yes,
how.
that's
So
yes,
then you replace it in the original equation, where now
yes.
you wrote everything squared, and then you took the D over the R outside the bracket.
Outside, excellent. Yes, I took it outside. That's excellent. Yes,
You spread the vector. Okay,
yes,
the first one over R, you know, you spread it.
yes,
Then you wrote the R over the D over the R outside, and then you wrote the vector. You wrote the other part, the F over the R. So that's how I understand it now. It's just
Mm.
spread
So
for
it's
now.
clear that it's clear, isn't it?
Yeah, on my side it's clear. I'm not
Yes,
sure
so
if
that's
you
what I wanted. We are just squaring. The first part, when you square 1 over r, 1 times 1, it's 1. R times r squared. When you square r as a vector, now it's r squared as a vector. Then when you square df dr, you are going to get the squared f dr squared. Then you can split it out by just saying d dr multiplied by df dr. That's, we just split it by taking d dr outside, like what we are outside the bracket. So should I continue now?
Yes.
Thank you.
Yeah.
All right. Thank you. If you are together there, then it's fine. You don't want to go very far, then we start coming back. Right. In general, let's go in general. When we say, in general, when we say, we now want to deal with this one. Can you see this one? Which is d r squared as a vector. R squared as a vector. What is R in general? First of all, you must know what is R in general. We know R as a vector. R as a vector is X. How many units in the X? X units in the I direction, which means it has moved how many units? X units in the I direction. Plus Y units in the what? In the J direction. Let me just zoom it a bit so that you see that sign. So we moved I units in the J direction. So we put our J here. And then plus. So it's a J with a head. Plus K units. Sorry. Plus Z units in the K direction. So K is a unit vector. So that is R, isn't it? Yes. So when you want R squared, which means we are going to use dot product, like what we were doing in question number 1. When you are finding if they are perpendicular, what we were using dot product. Why are we using dot product? Because we are trying to find R squared. We are trying to find R squared. So that vector R squared as a vector is equals to R as a vector. Then you dot product of R, another R as a what? As a vector. Is it clear? So it's two R's that I'm applying each other. Therefore, what is the answer? Then we dot our R's. So it's going to be equals to R, we said it's X in the I direction, we put with the head, plus Y in the J direction with the head, which means it's a unit vector, plus K plus Z in the K direction. Then you dot, so this is a vector. Now we are dotting that vector. So it's a dot product. Dot. Then put a bracket, X in the I direction, plus Y in the J direction, plus Z plus Z in the K direction. So this is dot product. That's what we are doing here. So which means we are going to say the first component multiplied by the first component of X. So it will be this one. When you are dotting, which means you are going to multiply this first component by this one. That's what we are going to do. So X times X, what is X times X?
X squared.
X squared. Let's continue in red. So we agree to each other. So X times X. So the result of dot product is a scalar. So which means this R squared that we are looking for as a vector, R squared, is equals to X squared. Can you see? X squared. Then the second component, but there is X times X. What about, what is I times I? What do you get in classical mechanics? What is the component vector? I dot I. What is I dot I?
Isn't it 1?
Yes, exactly, it's 1. J dot J is also 1. But I dot K is 0. You must know that. So I dot I is 1. K dot K is 1. Where is it coming from? From the unit vector. So which means you are only multiplying 1 times 1 from the component. 1 plus 0 times what 1. So which means it's coming if you don't understand why I times I is 1. I is a unit vector. I dot I. For example, I dot I. We are dotting the product. I is just 1, 0, 0. Then you dot it with I again, 1, 0, 0. That is the unit vector. So it's going to be 1 times 1. What are you going to get? Equals to 1.
Mm.
And plus 0 times 0, you get what? 0. Plus 0 times 0, you get 0. So the answer is equals to what? 1.
Mm.
Yeah. So you do the same for I, J, and K. So in other words, I dot I in general is just equals to 1. So that's what we mean, just equals to 1. So we are going to use that concept there. We are not going to be multiplying also I times I because we know already it's 1. So x squared times 1, that's x squared. Y times that y, which is the next one. Y times y, what do you get?
That's good.
Y squared. And then what is j times j?
1.
It's 1. So which means just plus. We are adding because it's dot product plus y squared times 1, which is just y squared. Plus, you do the same. Z times z, what is that? Z squared. Then k times k. K times k, k dot k, it's 1. It's not 0, it's 1. Then it's z squared times 1. So that's where we are, x squared. So in other words, we are saying r squared is equals to x squared plus y squared plus z squared. Now this is no longer a vector, it's now a scalar. So that, which means we are going to say, but we know that r as a vector, we know r as a vector, it's square root of what? Of x squared plus what?
Yes. Y squared.
The magnitude of r as a scalar, sorry. This one is r of a vector, it has components xi. I'm referring to magnitude of r. That r, the scalar one, without the vector on top. Only the scalar one. The scalar one, we say the magnitude, if you want the magnitude, is going to be equals to square root. It does not have a vector, this one. Square root of x squared. R, in general, the magnitude. Square root of x squared plus y squared plus z what? Z squared. Can you see it?
Mm.
That is r. So what is the relationship between r squared and r? If I'm to ask you, how are you going to write that r? Because we have calculated, how are you going to find the relationship between these two? Because there is a relationship here between these two. What we have calculated between r squared and r. What are you going to decide between these two? Because there are some things which are common here. If I just manipulate a bit, I can be in a position to remove that r squared, which is a vector, in terms of r, which is a scalar. So once you are done there, then you'll be able to solve this problem. What are you seeing from there between the r squared as a vector and the r, which is just a scalar? The other one as a vector, it does not have a what? A square root.
Good.
Then the r that is having a scalar quantity is having a square root. So how can we relate that r squared, which is on top, which is a vector? How can we convert it to a scalar? That is what we are trying to do. How can we convert that r to a scalar?
Are you not supposed to remove the square root by writing it in bracket and then 1/2?
So which means, in other words, that r squared, which is on top here, which is a vector, that r squared, which is a vector on top, is also equivalent to r.
Mm-hmm.
Can you see it? It's equivalent to what? To R. That R squared, which is having a vector there on top, is equivalent, not equivalent to R, but to R squared. Why to R squared? It's because if I square this square root, squared, I say squared, I'm going to get the top part of the vector. Is it clear? Yes. If I square the top part, the left-hand side, I square it like 2. Then the left-hand side, I also square again, R squared. I'm going to arrive at this point, where the R, which is on top, which is this one, is equivalent to R squared. Any question? How we arrive there? If you want to add something, you can add, so that we can conclude. We're calculating what is R squared as a vector. How do we convert it to a scalar? This R squared. This R squared, which is here inside. How do you convert it to a scalar? How do you convert it to a scalar? Is it clear now? Should we continue?
Yes.
Hello?
Yes, we
You said
can continue.
we can continue. Ne?
Yes.
There's a question, or we can continue?
There's no question.
There's no
It's
question.
clear.
All right. So if it's clear, then I'm here. So now we are going to use that relationship for us to solve for we want to solve for what is inside the bracket using grad squared log R of 1 over R squared. So we are going to be using this concept here, what we have found here, to solve for grad squared R log R over 1 is equals to 1 over R squared. So that is the idea that we are going to be using in solving that. So it's going to be 1 over R squared ddr of what is inside the bracket. So we are going to differentiate what is inside the bracket, ddr of what is inside the bracket, which means, and then df dr. All right. So let's start. Let's write on a fresh page like here. So our question now is grad squared. Grad squared of log. This is now my function. It's being specific now. Grad squared of log R. What is it going to be equals to from the question? In brackets, this is my function. F of R is log R. Is equals to what? So the formula, already we have derived it in B, that if you are given a function of R, then how are you going to write? If the function is in terms of R, automatically you are just going to come and use this part B as a formula, which means it's going to be 1 over R squared. So you come and put your 1 over R squared. So it's going to be 1 over R squared. So it's 1 over R squared. That is what you are going to do. Then you put your bracket, which is d dr. So it's d dr of what is inside the bracket, which means it's your vector now. The vector, which is R. So we put our vector R as a vector. But that R is being squared, R squared. Then we have d df. But in this case, it's no longer d dr of f. It's no longer d dr of f. It's ddr of log r. Your f is now what? Log r. So we are replacing f with log what? R. So it's dd, instead of putting an f, ddf. Now here you are putting log r. So it's d dr of log r. ddr of log r.
And where are we taking log R from?
ddr of log r. Yes.
Where are we replacing with log
Hmm?
R?
Why am I?
Writing log R from.
Isn't it here? We are having df dr. So what is f? What is our f? Our f is the function. So first you say let f of r be equals to log r. That is your first assumption. This statement must be written down. Let f of r be equals to log 1 to log r. You must write it down. So that wherever there is log r, wherever there is f, you are replacing f r with log r. That's the function. That's what we did. So that is what B is telling us. B is telling that whenever you find a function of fr, grad fr, this is what you do. But our question now is not asking for grad fr. It's asking for grad squared of fr. So whenever you find grad squared of fr, this is what you are supposed to do. To say 1 over r squared multiplied by d dr of r as a vector df dr. That is our rule. So wherever there is f, we are replacing f with log r. Is it clear? Is it clear? Wherever there is f, we are replacing f with what?
With log R.
With log r. Is it clear?
Hmm.
Thank you. So where there's f, we are replacing f with log r. So let's continue with our problem. So there we are. So let's continue, which is equals to, we still have 1 over r squared, which is there. 1 over r squared. We have our ddr still outside the bracket. Let's put it ddr outside the bracket. Then you put your bracket. But what was r squared equals to? What did we conclude about r squared? What did we conclude about r squared? R squared is equals to r squared of a scalar. This is what we concluded, isn't it?
Mm-hmm.
From here, from this step, this is what we concluded. That r squared as a vector is equals to r squared of a scalar by dotting, by dot product. So we are going to replace where there is r squared of a vector, we replace with r squared of a scalar, because we have already used dot product to prove it, that they are equal, those ones. Then what is the derivative of log r? If you differentiate log r, what are you going to get? ddr of log r. What do you get? Now differentiate ddr of log r.
It's 1 over R.
Thank you. That's correct. That's correct. So it's 1 over r. It's just like derivative of ln. Ln r, you get 1 over r. So here you am applying by 1 over r. I'm applying by 1 over r, which is the derivative of log r. Can you see where we are going?
Yeah.
Therefore, from there, we are seeing that there are like terms that can cancel, which means inside the bracket, the r, this r, can cancel with 1 of the r there. This one, r squared. But it will cancel with 1, then you'll be left with 1, isn't it? It's just like r squared divided by r. So we are left with what is inside the bracket. So that's what I want to show you. So let's rewrite it nicely and clearly without confusing anyone. Right, so which means our next step following the above is going to be equals to 1 over r squared which is DDR. DDR. What is left now inside the bracket? What am I going to write if you are following?
You're going to write R.
Thank you. You are going to write R. That's excellent. You are following. You are going to write R, which is equals to 1 over R squared. What is DDR of R?
It's 1.
That's where we are going. That's the one which we're debating about yesterday. Where
Hey.
is the so then equals to 1 over R squared. So that is it now, class. That is it. That is it. So we have many concepts that we talked about. Dot product. How do we convert R squared as a vector? R as a vector multiplied by the another R as a vector, which means there's two R's, meaning dot product, you get R squared. I times I dot I give you 1. So those are the physics concepts that you must bear in mind. And how do you write R, the magnitude of R only, not as a vector? R as a vector, it has components I, J, and K. But R as a magnitude, it does not have components I, J, and K. R as a magnitude does not have components I, J, and K. That's what. Okay. So after we did dot product, we found that R squared, which is a vector, is equals to R squared. Is equals to R squared. So we have used that relationship to say grad squared log R can also be written as, where there was FR from B, I replaced FR with just log R. Then I just do the same. So they can give you sine R, or they can give you e to the power R. You just do the same. Grad squared of e to the power R, you just do the same. It will be 1 over R squared, ddr multiplied by R squared as a vector, ddr of that function that you have been given. So we have proved this, that is coming back to the original, what we have been told to prove, which is we are supposed to show that it's 1 over R squared. So we've come to the conclusion that grad of log R, this is what we have been proving, to show that grad squared of log R is equals to this. So this is what we are supposed to be showing, and we have shown it now that it's equals to that. Any question?
I think it's clear.
It's clear. It's a matter of just writing it and writing it down nicely so that you score marks. And the key thing before you write, before you replace log R, please, when you are replacing log R, the first thing that you must write is this assumption. It must be stated already to say let, when before you start replacing log R, you say let FR, because this, you are already having this formula which you are substituting. So the formula that we're using to substitute is this one. From part number B, we use the B to solve C. We use the concept. So after this statement, which you have copied from B, you just set both left and right side. It can be written like that. So you say let automatically, then you now say let. After that step, you say let FR be equals to, let FR be equals to log R. B equals to log R. Then you put in bracket. So this assumption must be clearly stated. Let FR equals to log R. Then you can do the vector product. The vector R can be written as xi, yj, zk. But what is R squared? R squared is R dot R. You do your dot product. Then you show that R is equivalent to R squared of a scalar. And from there, you continue So problem, where there's r squared of a vector, you replace with r squared of a scalar. So because if I was going to explain that r squared of a vector is the same as r squared of a scalar, it would be incorrect. So that's why I showed you by proving it, those two dot products were the same. Then you differentiate ddr using your concept for log and ln. Differentiate ln r, you get 1 over r. If you differentiate log r, 1 over r. What is inside the bracket is cancelling. What is left now when you simplify is r. So ddr of r is 1. 1 is being multiplied by 1 over r squared. There we are. Any questions? Any questions, please? You have a question?
On the
So that you don't do hanging, I have to clarify.
can I was saying that can you please repeat the on the d over dr log r? How
Oh, yeah.
yeah,
Is it-
how is it 1 over r?
Oh, how is it 1 over r? How do you differentiate ln r? How do you differentiate ln r? Ln r is what? If I say ddx of ln r, what is ddx of ln r? Is it Clementine?
Yeah,
Yeah, ddr of ln r. What is your answer? Just differentiation. It's 1 over r. You must just know this one. When you differentiate ln, you get 1 over r. Yes, that one is just 1. And ln is just a log. Ln is just log base e of r is equals to 1 over r when you differentiate, which is the same as log. When I say log r, it's just base 10 of r, which is the same as 1 over r. So ln r and log r, they are just the same. They just give you 1 over r. Any logarithm that you are given, you automatically assume that it's given as a base 10. Log base 10 r. We normally use this logarithm with financial maths when we are converting financial mathematics. That's when we normally use this logarithm.
oh, right then.
So this is calculus differentiation. You must just know it. When you differentiate ln r, you get 1 over r. When you differentiate log r, 1 over r. Any question?
Yeah.
All right. So I will share the recording for this one, which you have understood, so that we disregard the one which you did not understand for yesterday. So I will share the recording as well. So I have another class, so let's call it a day for today. We will continue with that long question on Monday. Oh, sorry, Monday we have waves and optics. On Wednesday next week, Wednesday and Thursday.
Okay.
Yes, I will share the recording. Just remind me if I have forgotten.
Okay. You saying I must remind you what?
If I delay or if I have not shared the recording, just remind me so that I know.
Okay.